Welcome back to my channel. Our today's topic is how to make cement. Cement is a vital construction material used throughout the world as a binding agent. The word cement means bond. Material possessing binding property is called cement. Names of cement and concrete are often used interchangeably or entirely different products. Cement is actually one of the primary raw materials used in the production of concrete, along with water and aggregates. The process of making concrete begins with the production of cement, the crucial binding material that holds water and aggregates together to form a solid, durable structure. There are many types of cement, but the most widely used is ordinary Portland cement, OPC. This name was given because the final product resembles the color of stone quarried on the Isle of Portland in Dorset, England. High-quality cements require raw materials of adequate purity and uniform composition. Limestone or calcium carbonate and clay or shale are the most common raw materials used for the manufacture of Portland cement. These are the main raw materials used in cement production. The location of the cement plants is most often determined by the occurrence of suitable limestone deposits. Most common raw materials used for cement are limestone, clay, iron ore, silica sand, and gypsum. Limestone and clay, typically obtained from large quarries by blasting or heavy machinery. These materials are then transported to a crushing plant, where they are broken down into smaller pieces. The sequence of operation for the processing of raw materials may vary considerably from plant to plant, depending upon the raw materials, equipment, and plant design. In the wet process, each raw material is quarried, crushed, and stockpiled separately to provide feedstock of known composition. The second important step after crushing of raw materials for manufacturing cement is grinding of raw materials in the raw mill in appropriate proportions, where it is finely ground into powder. Grinding increases surface area, making chemical reactions more efficient and ensuring a consistent composition. After grinding, the powdered raw meal is fed to CF silo. CF silo or blending silo is an intermediate storage of raw mix before feeding to kiln through preheater. The raw mix is heated in a preheater tower using hot gases from the kiln. This begins the process of calcination, where carbonates in the limestone begin to decompose into calcium oxide, lime. From the preheater, the material enters a rotary kiln. The kiln is a very essential part of a cement plant. It is an industrial furnace to heat raw materials to produce clinker. It is a massive cylindrical furnace that reaches temperatures of around 1,450 degrees Celsius, 2,642 degrees Fahrenheit. Inside the kiln, complex chemical reactions take place, forming small marble-sized nodules known as clinker. These clinkers consist mainly of calcium silicates, aluminates, and ferrites, all essential compounds that give cement its binding strength. Once formed, the clinker is cooled rapidly in a clinker cooler using air. Cooling is critical to preserve the quality of the cement and prevent unwanted crystal formations. The cooled clinker is then ground together with a small amount of gypsum, which controls setting time, and possibly other additives like fly ash, slag, or pozzolana, depending on the desired properties. This process takes place at cement mill, where this final product is the cement we use in concrete. Finally, the cement is packed in bags of different capacities at packing plants. In packing plants, packers are there for packing of cement bags, as per requirement. Since cement is a vital ingredient in concrete, quality control at cement plants is rigorous. Laboratories frequently conduct chemical and physical tests to ensure each batch meets industry standards. Once the cement is ready, the next key ingredient is aggregate, which makes up as much as 75% of the volume of concrete. Aggregate includes both gravel, coarse aggregate, and sand, fine aggregate. Because of its versatility, strength, and availability, concrete, and by extension cement, is the most widely used construction material in the world. In the United States alone, over $4 billion worth of hydraulic cement is produced each year for use in over $20 billion worth of concrete construction. Globally, the concrete industry is valued at more than $600 billion, making it one of the most economically significant industries on the planet.